In this video, we're going to be working with arithmetic series. And before we talk about arithmetic series, you should be very comfortable with an arithmetic sequence, because an arithmetic series is representing the sum of the first n terms of an arithmetic sequence. So from a sequence to a series, you basically take all the commas away in the sequence and replace them with an addition or a subtraction sign, because the terms could be positive or negative. So what we want to do is find a formula to find the sum of the general arithmetic series. Okay, so there's a very famous story about Carl Gauss. He was asked to find the sum of the first 100 natural numbers, and he was able to do it very quickly. So this is probably what was happening in his mind. So he wrote the first 100 natural numbers, the sum of the first 100 natural numbers, in ascending order. And then he did it in reverse order. And then he lined them up in his head, and then he added that. He added the two rows, so now he's finding twice the sum of the first 100 natural numbers. And if you look at the sums from each row, you get 101, 101, 101, 101, 101. You're adding 101 quite a few times. Well, the question is, how many times? Since you're adding 100, the first 100 natural numbers, you're adding by 101 100 times. But 100 times 101, that's not the answer, because this is equal to twice the sum of the first 100 natural numbers. So what you have to do is take the product and divide by 2, and there's your answer. So the sum of the first 100 natural numbers is 5050. So what we're going to do is take his idea and create the formula to find the sum of the first n terms of an arithmetic series. So what you can do is say the first term of the arithmetic series plus the last term of the arithmetic series. You're going to add them and then multiply by the number of terms you have in the arithmetic series. But remember, that product is twice as much as what you want. So we're going to take the product and divide by 2. And the last term of the arithmetic series is t sub n, right? So you can use the general term formula, a plus n minus 1d, to create another version of the arithmetic series formula. So you know what? Let's try to use the formulas. Determine the sum of the first 10 terms of each arithmetic series. So we're told A, we're told the first term, we're told the 10th term, and we know the common difference. You know what? We don't really need to know the common difference, because if I know the first term of the arithmetic series and the last term, then I can find the sum rather easily. So I'm going to use this version of the arithmetic series formula. So I'm just quickly triple check. 40 times 5. Yep. All right, so for 1b, now here I don't know the 10th term. Now because I don't know the 10th term of the arithmetic series, I can't really use this. I can solve for the 10th term and then use this version of the arithmetic series formula. But you know what? I might as well just use this version, so I'm not even bother solving for the 10th term. So the sum of the first 10 terms of this arithmetic series, so it's 10 over 2, 2 times negative 4, and 10 minus 1 times negative 3. Well, punch that in, and let's see. So that's negative 27 minus 8 times 5, negative 175. So the sum of the first 10 terms of this arithmetic series is negative 175. Beautiful. All right, so this time we just have to do a little bit more work. They don't tell us what the common difference is. No problem, we can do that. That's why I said it's very important for you to be comfortable with arithmetic sequences before you work with arithmetic series. All right, so d is equal to positive 4. So the sum of the first 15 terms, let's see, I have to use the longer version. No problem. Okay. $60. Okay. I know the terms of the series look a little funny, but it is what it is. No problem. So the common difference here, you're adding by 9m. 9m is the common difference. So sum of the first 20 terms. Once again, I don't know the 20th term of the arithmetic series, so I'm going to use the longer version. For 1,490m. Okay, so that's a good start for using arithmetic series. Okay, so for example 3, it says determine the sum of the 7th term to the 11th term of an arithmetic series where A is 4 and D is 2. Okay, let's think about it. They want the 7th term to the 11th term. So what I'm going to do is I'm going to just write, I'm going to write the terms like 1, 2, 3, all the way up to 11. That wasn't very pretty, but you know what? I think we'll live with that. Okay, so I have the first 11 terms here. Now, I don't want the sum of the first 11 terms. I want the sum of the 7th to 11th. So I want to take away these 6 terms here. I don't want the sum of the first 6 terms. So you know what? I think we can figure out a strategy. So the sum of the 7th to 11th term is equal to the sum of the first 11 terms minus the sum of the first 6 terms, right? And then I'll be left with 7, 8, 9, 10, 11. All right, so how do you find the sum of the first 6 terms? Well, I do have A and I do have D, so let's punch it into the formula. So 2 times A and minus 1D. D is 2 here. Minus 6 over 2. All right, let's see here. So that's 54. So this is 54. What's that? 10 times 2 is 20 plus 8. So it's 154 minus 54, which is 100. Oh, that worked out too nice. It was perfect. I'm just thinking if there's another way you can do this. I guess you can think of this. You know what you could have also done is solve for the 7th term of the arithmetic series and then create a new arithmetic series where the 7th term is your first term and find the sum of your first 5 terms of this new arithmetic series you're creating. I am curious what the 7th term is. Let me just check. So the first term is A plus 6D. So A plus 6D is 4 plus 12 is 16. So this is 16. You know what? Let's check. 16 plus 18 plus 20 plus 22 plus 24 is 100. Perfect. I'm feeling great. Yeah. Because you have a calculator on the test, you can easily check. I mean, it's a little tedious. It feels like a much, like let's say the 7th term to the 1000th term. That's a lot more work, but if it's like just 7 to 11, I think I can do that on the calculator. All right. So determine the sum of the arithmetic series. So you have 3 plus 8 plus 13 plus all the way up to the 58. The problem is I don't know how many terms I have here. I have no idea how many terms I have here. But luckily, I know this is an arithmetic series. So 58 is equal to 3 plus n minus 1 times, what's the common difference? 5, right? This comes from the arithmetic sequence. T sub the general term is equal to a plus n minus 1d. So I can solve for the number of terms in this arithmetic series. So it's 55. Oh, 12. There are 12 terms in this arithmetic series. Beautiful. I can find the sum very quickly now. So that means 12 over 2. And we use a short version because I know the last term of my arithmetic series. So 3 plus 58. So 61 times 6. Yes, of course, 366. All right, so the sum is 366. At a logging camp, the tree trunks are piled up in a pyramid shape ready for transport. The first row of trees has 34 tree trunks lying side by side. The next row has 33 tree trunks. Each successive row has one fewer trunk, and the top row has 8 tree trunks. So you know what? Let's just 8, 9, 10, all the way down to 34. So what we can do is start from the top of the pyramid and visualize this as an arithmetic series, or start from the bottom of the pyramid and go up. Doesn't really matter. I'm going to start at the top. So imagine this is 8 plus 9 plus 10 plus all the way up to the bottom row has 34. So that means A is equal to 8 and D, the common ratio is, the common difference is 1. So how many tree trunks are all together? I really want to know how many rows I have. So that's how many terms I have in this series. So just like before, I'm going to solve for the number of terms, which represents the number of rows of tree trunks. So A plus n minus 1d, d in this case is 1, makes it very easy. So 34 minus 8 plus 1 really, so it's 26 equals n minus 1, and then n is 27. Alright, so I have 27 rows of tree trunks. That's nice to know. So use the arithmetic series formula. I'm going to use a shorter version because I have the first and last term of the arithmetic series. So 27 over 2, 8 plus 34, 567. Therefore, there are 567 tree trunks altogether. All right, so that's the lesson for arithmetic series.